Okay, so we're going to evaluate this integral, and it's in the form of a sine function on top and a cosine function on the bottom in a square root. So when we're dealing with these ones where the cosine in the bottom, it's like a 1 plus cosine x or a 1 minus cosine x, what we're going to do is we're going to rationalize the denominator by multiplying the integrand by the conjugate. So the process is going to be, first we'll rationalize the denominator. Then we're going to apply the Pythagorean identity. For cosine squared x plus sine squared x equals 1. Then we'll do a u substitution. I didn't spell that right. Do a u substitution. And then we'll evaluate. So, beginning with 1, let's take the integrand. Seven sine squared of x divided by the square root of 1 plus cosine x. And what we'll do is we're going to multiply it by the conjugate. So what that is, or the conjugate of the denominator. So what that is it will be the same as the denominator, but the terms inside will be subtracted from each other rather than added. If the denominator was 1 minus cosine x, then the conjugate would be 1 plus cosine x. In this case, since the denominator is 1 plus cosine x, the conjugate is 1 minus cosine x. And so we're able to multiply this because this is 1. You know, we have the same numerator and denominator, it's 1. But what this will enable us to do is multiply the denominators together like so. We'll get 1 minus cosine squared x. Now, the reason we use the conjugate was so that we wouldn't get those middle terms. For example, if we wrote 1 plus cosine x over 1 plus cosine x, we would end up with 1 plus 2 cosine x plus cosine squared x. And then we wouldn't be able to use the Pythagorean identity. So with this Pythagorean identity up here, cosine squared x plus sine squared x equals 1. That means that sine squared x is equal to 1 minus cosine squared x. So we can rewrite this as 7 sine squared x times the square root of 1 minus cosine x divided by the square root of sine squared x. And now this thing's getting a little easier to deal with. We can take the square root on the bottom. The top will remain the same for now. And the square root of sine squared x will just be sine x. And now we can cancel out one of these here, one of the sines. So we'll get 7 sine x times the square root of 1 minus cosine x. And that's a lot easier to deal with. So from here, we can rewrite the integral. What was the integral from? 0 to pi thirds? Yes. The integral from 0 to pi thirds of 7 sine squared x over the square root of 1 plus cosine x dx is equal to the integral from 0 to pi thirds of 7 sine x times 1 minus cosine x. Let me just double check and make sure I got that right up. Yeah, that's the starting integral. Okay, so from here we can use a u substitution. We'll let u equal 1 minus cosine x. So then du will be, let's see, it'll be sine x dx. Okay, and we've got a sine x. Oh yeah, here's a dx here. Got a sine x dx here. So now let's change our bounds of integration. When x is equal to 0, u will be, let's see, cosine of 0 is 1. So 1 minus 1 will be 0. Now when x is equal to pi thirds, u will be equal, cosine of pi thirds is 1/2. 1 minus 1/2 will be 1/2. So this will be equal to the integral from 0 to 1/2 of, let's pull this 7 out, 7 times the square root of u du. Because the u is 1 minus cosine x inside the square root, the du is sine x dx. Here's the sine x dx. And so this is what the substitution turns it into. And now we can easily evaluate this. This will be equal to 7 times 2/3 u to the power of 3/2, evaluated from 0 to 1/2. Now we just have to evaluate it. What we'll get is 7 times 2/3, it's a funky 3, 2/3 times 1/2 to the power of 3/2 minus, and if we plug a 0 in here, this is all going to be 0. So our final answer will be 14/3 times 1/2 to the power of 3/2.